Thank you for making some time to speak with me about the topic powering smarter manufacturing. I was very glad you could join because we had some conversations, of course, in the past. You're deep into the manufacturing and energy space. So maybe we could start off by you sharing what your role is, which company you work for, and how you are interacting with the field of energy management.
Yes, thank you, Thomas, for inviting me here. So my name is Franz Bosbach. I'm responsible for business expansion at KSB. So first of all, KSB, what is it? We make pumps and valves globally from a small circulator, 40 watt, for heating systems up to 56 megawatts for power plants and everything in between. And even for stones and whatever you can think about what could be pumped or on the other hand should be shut off with valves. And I'm in the department for energy, so power plants, renewable energy, heat pumps, and so on. And my role is to find new solutions for KSB internally, but also for new business systems for our customers to deal with anything with energy in general. So we are talking about heat, we are talking about electricity, power optimization, and so on. That's why we got into contact.
Yeah, exactly. From other customers of ours in the industrial field, we know that pump power can be quite significant, of course, for definitely in some industries. You highlighted a couple of them. So you make something that consumes quite some electricity downstream with your customers, but probably just the making or manufacturing these pumps in itself is also quite energy intensive. Can you maybe frame that a bit? Is it effectively the case? And you highlighted already that you have both an internal facing and external facing role, so that would play a bit in that dynamic, I would say.
Yeah, the main point is that we really produce hard goods, pumps, valves, and for that we use in every plant some megawatts of electric power. And of course, we want to optimize that. But if you take a cake of a life cycle of a pump or of a valve, then this time of producing is neglecting. So we are talking about 60 megawatt pump, then of course if it's running 24/7, it's using way more electricity than our whole plant. And normally 80 to 95% of the overall electricity used for the product is in duty phase. And there we know due to wrong design, we can normally save roughly by optimization the full system 40 to 60%. So that is a huge level we are talking about to influence our third level of energy use, so at the customer side. And that is really interesting. And in the past, I have some pumps, it's fine, but not touch a running system. But due to energy crisis and the discussions ongoing, we see now it's more and more relevant to optimize the systems even with the big pumps. And so a lot of our pumps have more than 1 megawatt power. And so this could be relevant for direct active steering in different electricity markets. And that is an external phase, but also on the other hand, if you have a standard pump, everything is regulated already in such a high way that if you buy in Europe a water pump, the efficiency is so high regulated, excuse me, that you can normally neglect the duty phase since it's so high regulated, and then it drops back. Of course, it's 95% of the duty phase is really the amount of electricity, but this is fixed to high standards. And then the last 15 to 5% of the energy used during production keep a relevant role. And everything is the same with all competitors. And that's where we're dealing with is now to optimize also our internal energy use for producing the products. Since, of course, normally you could say it's neglecting compared to the efficiency outside and the use phase. But now we're going back and step to say, okay, also the electricity we use to produce the product is relevant
Yeah, I understand. So you say that, okay, you make pumps, it's an energy intensive thing by design, and then you have the total pie of electricity that goes into the pump. There's some in producing it, and the other piece of the pie, and the biggest one you say is running it, so the duty phase. And is it true that you just described as well that while the duty phase is the biggest pie of the electricity consumption, that there it's also quite hard to unlock this flexibility or to really influence and steer the electricity consumption? I can imagine that for KSB, you sell something to a customer, and it's not necessarily easy to then develop offerings around steering the pump while it's in duty. Uh, while when you're working internally, of course, you have all levers in your own hands and you can basically do what you want as KSB. Can you share a bit on, yeah, this flexibility at your customers, and what are the common sort of hurdles your customers are looking into overcoming when developing more flexibility?
Yeah, that really depends on the application. So if we
Yeah,
are talking about applications like wastewater or stormwater, of course, if there is water, it should be pumped away. So there's no possibility to be flexible on an energy market. But if you go to groundwater handling, for example, to keep it on a different level, then normally the system is so slow that you can say, okay, I just pump with two pumps during 8 hours. The sunshine is shining, and I take free or really cheap PV electricity, and then during night, the level will go up for 20 centimeter, and everything is fine. And that are applications we can normally flexibilize. But of course, that is always a question of design of the product. Since in the past, nobody was interested in, and of course, all the products are designed for 24/7 running. And now we are talking to be flexible, and then you have to make sure that all the bearings, all the designs are able to shut on, shut off 8 to 20 times a day. And normally they are designed for one start stop per day. And that, of course, will have a lot of other frequencies and other behavior of the products if you really switch on and off. But we have seen in some prototypes already that our design are really suitable for that, and it's not a critical part. But since nowadays it's designed for and also official sold to the customer with these duty points, no customer for their own willingness will start to switch off the pumps
yeah, indeed.
very often. And that is something we have to find out. What are the possibilities? And that's why a lot of energy flexibilization we see in, for example, air, pressurized air, compressors, and so on, and not on the pump side at the moment, since air is always start off and you have a lot of compression and you can store it easier. If you are in a heating system, you have incompressible media with water, and so you're not the prime source for the future or for the duty. Pumps, especially for heating, are always secondary, and you don't want to switch off your primary process since the pump should run in another time. And so that
Yeah.
makes it more complicated compared to compressors, for example.
Yeah, there we see that often as well, that in these compressible media, like there's often more buffer capacity already on site than comparing it with, for instance, heating applications. It's not a given yet. But it's very interesting that you say there's a design phase, which is really core to your product. But then, of course, there is a customer facing aspect as well of probably educating the customer on the benefits, the possibilities, and then working with them to make sure that they get the most out of the equipment you supply them. Can you share some, yeah, maybe some anecdotes or examples or the way you work around that to really make sure that customers know that this is a possibility and that they know about the potential benefits they can gain?
So we are sharing these insights regularly today, but also with our core customers always, since it is getting the customer getting interested. And so we are still discussing to have some demo plans here for these applications. And you already told me in the last call that it is also, for example, desalination, a typical part. where you say, okay, we want to desalinate water. Of course, these pumps are running then with PV or renewable electricity, and then you produce pure water during cheap electricity times instead of 24/7. Since pure water you need in your processes, you can store with some tanks, and that's really easy. And so we come from an energy design in general, where everything should be run smooth. And
Yeah.
now we have to go flexible, and that will tackle all the topics we see around. And of course, in the past, it was mandatory that the pumps are running 24/7. In the past, compared to 20th century. If you go back in time, for example, in Netherlands, the head is windmills, of course, yeah? And all these windmills in the past were delivering power to the pumps. Since from the system it was, if there's wind, you have groundwater. And then with the wind, you can level the groundwater. And that's typical from the past. And if you think about the cliches about Netherlands, windmills, it was not windmill for corn, it was windmill for pumping. And
Yeah.
so this flexibility with pumps was originally by design, but we did, didn't we forget this task in the past since we had 24/7 fossil electricity, and we have to use it during all the time to keep the costs down. And now we have cheaper costs during special time frames, and that
Yeah.
shifts again back to the original design in the past, where you just pump when the wind is blowing.
Yeah. Do you then also see a change in, first in sizing of assets? Because if a system is designed to operate also only half the time when there's, for instance, renewable energy available, yeah, it might need to be bigger or more powerful to be able to have the same workload in the end versus a system which is running continuously, which might be a bit smaller in terms of design. Do you see a trend of getting oversized assets to then be more flexible in the operation?
Yeah, that's a good question. It is not a trend. We are normally working against this tradition. Since if you're a good engineer, what do? You want to design something to make it, it could work a little bit bigger. And then you give this to a planner. It starts, I'm not sure, I make it a little bit bigger. And what we've seen during the last decades that most hydraulic systems, pumps, are all over-designed
Okay.
already. And most of them are not running single, but mainly 2 or 3 times 100% pumps in parallel, that you can switch from one to another for repair and so on. And so we see very often that you have, instead of one pump running 24/7 in a duty point, this duty point normally is way higher. So the one pump could pump more. And additionally, we have 1 or 2 pumps in parallel for switching. So
Yeah.
the installation normally is always, at this times, coming from traditional, over engineering, a little bit more safety, a little bit more space for design in the future. All of these normal pump installations are too big and can
Okay.
be
Yeah.
handled more than they have to. And so normally we can really match here over designed systems from the past, running them in a shorter time with a normal duty count, reducing the losses during this time since the pump is running in the best efficiency points, and then switching it off during times where the electricity is too expensive.
Yeah. So you say it's not really a recent trend that's now popping up, but it has been going on for quite a while, that there's just a tendency to over-engineer
Yeah.
these kind of assets. Very, very insightful. If you then think about running them, so meaning that you want to flexibilize some overcapacity, we often see that it requires then real-time information about electricity prices. It might require connecting to grid mechanisms, that you get some revenue by supporting grid stability. This is often something new for industrial companies. How do you see there some typical hurdles that you can help companies with to be part of those mechanisms, to understand understand really how and where they can find value with flexibility?
Yeah, the main part is starting to think about that. Yeah,
Yeah.
since, for example, we at KSB, we have a standard contract with, I think, about 80 to 90% of electricity permanently bought in front, 1 or 2 years in front. So we have good prices, but less flexibility. And now we see during the last 5 years that spikes in the prices are getting higher, but also the valleys. And then, of course, after some time, you have to decide: is it interesting business case for us or not? Will we stay? Everything is fine. You have your contract, and it's run smooth. But then you think, okay, how much money I waste? And that is where we started to discuss about, okay, is this a relevant amount of money or not, and then how to start. And then the second part is really, do you have all the data already? Or can you really analyze your system? Or do you need smart meters or some measurements from your facilities to really identify what you are really use? And then you can go to platforms like Companion to analyze and use it in lifetime and optimize the systems. But that is, of course, from the past. We have one plug. Plant is running and everything is fine, and at the end you have a bill. And now with this increasing energy prices, we really have to look in detail which building is optimized and so on. And that is still a bottleneck for smart meters for electricians to
Yeah.
install it. Since our plant here in Frankenthal is about from 1871 built up, and so we have really old parts, new parts, and so in the past it was no matter, and so we don't even have a lot of meters
Yeah.
to get all these insights. And that is for industry the biggest challenge, to install all the meters at the very beginning, to analyze, and then the solutions are ready to discuss flexibility. But of course, if you're talking about flexibility, it's also other questions, especially in Germany, you have to talk about. If we have a fixed shift systems and the people have to start at 6 o'clock in the morning, then you have to start the heating system, all the machines at 6 or 6:30, depending on time. But the sun goes up at 8 or 9 in the winter. And are also the people flexible enough to change their behavior?
Yeah.
And so we have seen in Germany some companies already shaping also the use of electricity for melting, for example. And they say, okay, we start with all people start 2 hours later to
Yeah.
make sure that we have PV current for our ovens. And of
That you
course,
even have
that really,
planning flexibility really of the shift planning
yeah,
even to
yeah,
reduce costs.
yeah, for example. And that are a lot of possibilities, but you have to talk to the people, you have to convince the people, and you can't say, okay, no, everybody starts at 10 o'clock in the morning to start working, since everyone is used to go home at 5 or 6 p.m.
Yeah.
And of course, everything is shifted, and that's the main question: what are the benefits after all? Electricity at the very end is not just one cost factor between others. And then we have to balance what can I reduce on the electricity bill, but have other topics. Price will increase during flexibilization.
It's a very interdependent topic, right? As you said, you cannot just be happy about saving some energy costs, but then have huge opportunity costs by doing so somewhere else. It's really a balancing act, also between cost efficiency, cost predictability, but also now the topic, as you say, around sustainability and embedding more renewable energy sources into the energy mix is for many companies a big priority. Again, on KSB as selling pumps and then the duty phase, how do you then try to bring in energy management? As I like the fact that you see it as a commercial point as well, and making your customers successful by proving the case as KSB and have some testing plans and proof of concepts on your end. How did you start doing that, and do you see still a big future for KSB in developing commercially facing energy solutions?
Yes, that's the main point here. At the core, we are delivering pumps and valves. Yes, and we are discussing what are our future role. It could be the lowest point that we guarantee some kind of our products are able to work on flexible on grid with
Yeah.
all the parts. That would be the lowest level. But of course, if we are talking about big pumps, more than 1 megawatt power, then it could be also that we design with the customer together a solution which is so well designed that it automatically work on a grid, for example, depending on the application always. But that could be also possibilities that we say, okay, in this niche market, wastewater mixing or whatever, there we can make sure that this solution works as a business case. But here we are really in close contact with research parties and customers, since the idea is pretty clear, but not just we and researchers, but also customer have to move for a prototype in this case. And we have a lot of interested customers saying, okay, if you have shown it, then we can start. But
Yeah.
of course, just installing a pump for showing that it works is no business case. So
Yeah.
it's always some kind of, okay, somebody has to move to. We have some customers mainly on the grid level. They are really interested in this topic, since if you have a look on the 3 gigawatt we bring to the grid in Germany per year, it's a huge amount of flexibility we can
Yeah.
realize, and it's really across whole Europe. And so not just one big energy storage, we have a big fleet of pumps there who can optimize that. Then this is really relevant for the grid uh, supplier in Germany like Tenet and so on. And they are always interested in such topics, but they aren't allowed to do it their own, since it would be an energy storage legally, and they are not allowed to run energy storage. And
Yes.
so
Yeah.
that
Yeah.
is a
They need
little bit
to
of
balance the
mixing.
grid.
So
Yeah.
the market is not ready from our side that it's a standard business case at all. And so we need more willing customers to go into such a demonstration plant to show that it's really work.
Yeah, it's still something new, right? It's
Yes,
something that the innovative players, they move ahead, and I mean, I hope for them that they have a good also first mover advantage into these markets, because if everybody starts doing it, it will become more competitive and the value will stabilize a bit as well. But I truly believe that the companies that make progress early on this topic, that they will also be the one that have a competitive advantage even on their electricity spend versus their competitors.
yeah, that's
Mm.
true.
Yeah, let's hope and that there is a good cases out there, good case studies. I think it's also a big point of showing the value. If you have a demonstrator plant, if you have an innovative case, that people communicate about it and also share the learnings with others to inspire them.
Yes, that would be really great, since we know that there's a really big level, but in pumps, since roughly 10% of electricity globally is used in pumps.
Yeah.
And if you're talking about decarbonization and all the possibilities now with renewable electricity, we need really more flexibility. And if you know that there is same number of flexibility possible in pumps like in the electric vehicles, comparable, that's really a possible game changer for the system, since they are already installed. It's just adding some control on these pumps, and then you can switch this flexibility on.
Yeah. Okay, very interesting. Yeah, I hope, or that's at least our mission with Companion Energy too, that we help companies with an established asset, an established fleet to make more out of it and basically get more value for investment that you are already done or that you will do as part of the energy transition. Franz, we're through our half an hour quick webinar and
Yes.
interview. I want to thank you a lot, Franz, for sharing your insights. Always much appreciated, and I think many companies can learn a lot from the approach that KSB is taking here to look at the sort of internally and both externally with your customers and suppliers of making this a success and unlocking more flexibility. Also astonished by that little fact that it's 10% of the global consumption is pumped power. Yep, thanks a lot, Franz, and I'm sure many people will get good learnings from this conversation.
Yeah, thank you, Thomas, having me, and have a great week. Goodbye.
Yes, you too. Bye bye, Franz.